Topic 3, the third and final topic in Module 1. Congratulations, you have made it to the last, or to the ending of Module 1. Alright, in this topic, we're going to talk through arithmetic and geometric series. We're going to go over two objectives in this video. Objective 1 is to introduce the concept of what a series is, discuss series and summation notation a little bit. And then in Objective 2, I'm going to actually put this into practice, so I will do a problem, and I'll ask you to pause the video and try one on your own to check your understanding, and then you're going to try 5 of these on your own, alright? So, back to Objective 1 though, an introduction to what a series is. A series is the blank of the terms in a sequence. All that the word series means is sum, alright? So when you see the word series in this module, you think sum. What that really means is we're going to add up all of the terms of the sequence, all right? You should be familiar by now with a list of terms being a sequence. Sum, or a series, just means that it will be presented to you as this. It will be addition in between each of the terms. All right. So if you're given a list of numbers with addition in between each term, you know that it is a series and that you're trying to find the sum. That's all it means. Arithmetic, geometric series, you're adding up all the terms of a sequence. Now, at one point in the mathematical journey, this would just have to be done longhand. If you're given a long list of numbers in a sequence and you want to find the sum of it, you just have to add them all up. But at some point then, like it did for any other part of math, a formula was created. So these are the two formulas we're going to work with for this entire topic. All right, so you have to become very familiar with these formulas. And just like there was for explicit formulas for a sequence, there was an arithmetic and geometric explicit formula, there's still going to be an arithmetic and geometric series formula. And they are as follows. The arithmetic formula is S of n, just meaning the sum of any given number in the sequence, is n times ace of 1 plus ace of n all over 2. And geometric is ace of 1 times 1 minus r to the n all over parenthesis 1 minus r. So if you notice there are some differences between the two formulas. The main difference is that the geometric series has an r, and it also has a variable in the exponent. That's how I tell the two apart. Alright? So when utilizing these formulas to find the sum of a given sequence, these are the steps I want you to follow. And they're just more guidelines. The actual math comes after these steps. But the first step in doing this is to determine if the terms in the sequence are arithmetic or geometric. Alright? That is pretty much the first step in any of this module. If I'm given a list of numbers, a sequence, I need to determine is it arithmetic or geometric. And we've done this before. We do this by either finding the common difference or common ratio. After we find that piece of information, we have to identify other pieces of information based off the formula, and I'll talk about that. And then I'm going to input all the relevant information into my formula. So let's put all this into action. Objective 2 states to evaluate the sum of a series. And this is technically your practice worksheet as well, but I'm going to go over 2 different examples, and then I'm going to have you try 2 different examples within this video to check your understanding, and then you're going to try 8 problems on your own. Again, the goal of mastery is to get them all correct. So, the direction state for these problems, evaluate each series described. Evaluate is just a fancy word for find the sum. I guess evaluate each series is just a fancy couple words for finding the sum of the series. So, I've listed the steps in red. And again, the first step is to determine is this arithmetic or geometric. I'm going to do number 2 over here. So again, to find if it's arithmetic or geometric, I have to find does it have a common difference or does it have a common ratio. Now, to kind of point me in the right direction, these numbers, negative 35, negative 44, negative 53, negative 62, they look to me like they're changing by something very similar each time. and I know that to be true because they're not increasing or decreasing at a very quick rate. So that just is a hint that maybe this is arithmetic, so I'm going to try that first. My first step, I'm going to see if it's arithmetic. So I'm going to take the second term, negative 44, and subtract the first term from it, negative 35. That gives me an answer of, subtract a negative turns to plus, negative 44 plus 35 is a negative 9. So far so good. Let's check that work. Let's go to the third term, negative 53 minus the second term of negative 44 also equals negative 9. So it is indeed arithmetic because it has a common difference of negative 9. I have done step 1. I know that it's arithmetic. I needed to do step 1 because now step 2 states find the unknowns of the formula, whatever formula we're needing to use. And if I reference back to this sheet, I defined it, sorry. I'm using this formula, the arithmetic series formula. I determined it's arithmetic, so that's the formula I need to use. I will write that down for reference. So I have S of n equals n times a sub 1 plus a sub n all over 2. Because it's arithmetic, that tells me which formula I need to use, and now it says find the unknowns of the formula. In this case, there are 3 unknowns, n, a sub 1, and a sub n. Alright, n and a sub 1 are pretty straightforward. N is given to me, right here. It tells me 17. There's going to be 17 terms in this series. A sub 1 is also given to me, right here. It's the first term listed, negative 35. But a sub n, I'm going to have to do some extra math. Alright, so that's what I put in step 3. If it's arithmetic, which this is arithmetic, I need to find the explicit formula to tell me what my a sub n is. Alright, so for step 3, I will do right here. I need to find the explicit formula. Way back in earlier learning in this module. A sub n, again the parent function for the explicit formula of an arithmetic sequence, is a sub n equals a sub 1, which in this case is negative 35, I found right there, negative 35, plus my difference, my common difference, which I found over here. But again, the difference is negative, so I'm going to subtract my difference, minus 9 times n minus 1. And in this case, for a sub n, we want to find a of 17. All right? It tells me my n is 17. So a sub n is going to be a sub 17 equals negative 35 minus 9 times 17 minus 1. This is going to give me my a sub n in this case. All right? So I'm going to write a sub 17 equals an unknown, but I'm about to figure that out. Negative 35, I'm going to plug in my calculator. Negative 35 minus 9 times 17 minus 1. It's negative 179. So I have found my a sub n. I have found my, let me finish this off. A sub 17 equals negative 179. So this might be a little harder of a concept to grasp, but a sub n just represents whatever nth term we care about. In this case, they told us we cared about the 17th term, and so my a sub n is technically a sub 17, which in this case I found with my explicit formula equals negative 179. So I have done step 2 and step 3 in this case. I have found all of my unknowns. I found this one, and this one. Now, step 4 is just to input this into the sum formula, all this information into the sum formula, and then solve it. So step 4, I'm going to reference this formula again. So I'm going to put S of n equals n, which in this case is 17, times my a sub 1, which is negative 35, plus my a sub n, which I found from my explicit formula is negative 179. All of that is divided by 2. So S of n is going to equal, let me input all that into my calculator. And you can go ahead and enter this in exactly like you see it, 17 parenthesis, negative 35 plus negative 179, close the parenthesis, and then divide all that by 2. And I get my sum to be negative 1819, or negative 1,819. And I am done. So, at this point, go ahead and pause the video and try number 1 on your own, following it step by step, just like I did, to check your understanding. At this point, you should have paused the video and tried number 1 on your own. I have shown all my steps, all 4 steps in blue here. The first step was to determine if it was arithmetic or geometric. I said that it was arithmetic because I found a common difference of 5. And then I identified in step 2 all the unknowns of my formula. Because it's arithmetic, I use this formula from our notes, and I had to identify n, a sub 1, and a sub n. N is given to me, n equals 18 from the problem. A sub 1 is the first number in the sequence, which is 11, or series, I'm sorry. And then a sub n, I need to define based off of my explicit formula, and that's what I did in step 3. I found my explicit formula. A sub n equals a sub 1 plus d, but instead of a sub 1 and d, I use what it is. So a sub n equals 11 plus 5 times n minus 1. And then they want a sub 18, because our n is 18. That's what I put here. A sub n technically equals a sub 18. And when I evaluate a sub 18, I put 18 in for n right here. And so that math gives me a sub 18 equals 96. So I have done all of step 2. I've identified all of my unknowns. And then step 4 just says solve formula by inputting my unknowns into the formula. So I have S of n equals 18 times 11 plus 96. Because again, if you look, n is 18 in this case, a sub 1 is 11, a sub n is 96. That's where I'm getting those numbers. And all that is divided by 2. So once I enter that into the calculator exactly like I see it, the sum is 963. I know that is a lot, but if you follow it step by step, it will limit your errors and you're more likely to get the correct answer. If your work doesn't look like mine and if you didn't get that for your answer, please check with a neighbor and see if they can answer your questions, and if not, please raise your hand and I'll come by and check your work. I still need to cover how to do geometric series, but I'm running out of time in this video, so I'm going to make another video.